So if I asked you to find the cosine of 15 degrees at this stage of the game, you would have no idea. All we know are the common angles. All we know are 0, 30, 45, 60, 90, and the reference angles around the rest of the unit circle of those angles. But cosine of 15, we have no idea. But if you notice that cosine of 15 is the same thing as the cosine of 45 degrees, which we would know, minus 30 degrees, which we would also know, this would be super easy to solve. The only thing we need is something to tie 45 and 30 degrees together in the cosine function so that we can operate and solve for the cosine of 15. And we have sum and difference identities. And there's a really beautiful proof of them on page 337. I'm not going to go through the proof. I'm just going to give you the identities. These are not identities you have to memorize, but they are identities that you should be really familiar with. So the first would be on the cosine function. So the cosine of alpha plus or minus beta. So that just means if you're adding it or if you're subtracting. The identity that you can use to solve this is the cosine of alpha times the cosine of beta. And in this case, the sign is going to be the opposite. So if you're adding two angles, then you want to subtract. And if you're subtracting two angles, you want to add the sine of alpha times the sine of beta. So in this case, alpha would be 45, and you can find the cosine and sine, super easy of that. And beta would be 30 degrees, and you can find the cosine and sine of beta, super easy as well. So that's one. There's also a sine, sum and difference. And this one shakes it up a little bit. You take the sine of alpha and the cosine of beta, and then the sine SIGN would be the same. So if you're adding alpha and beta to get your angle, then you would add in the identity. If you're subtracting alpha and beta, then you would subtract in the identity. And this time it'd be cos alpha sine beta. And then there is a tangent form. And the tangent form is tan alpha tan beta. It's a fraction. Tan alpha plus or minus tan beta over 1 minus plus, so the opposite sign, SIGN, tan alpha tan beta. So these are totally pluggy-chuggy, so let's just do them. If we want to find the cosine of 75 degrees, now the tricky part is finding a combination that works for you. In this case, it's pretty easy. 75 degrees equals, well, let's write it here, the cosine of 30 degrees plus 45 degrees. Okay, so we're just going to pluggy-chuggy the cosine identity. This gives us the cos of alpha is 30 times the cos of beta is 45. Now the sine, I'm adding, and so add, subtract. I'm going to do the opposite sign. Sine of alpha, which is 30, and sine of beta, which is 45. And so now we can put this together. Well, the cosine of 30 is root 3 over 2 times the cosine of 45 is root 2 over 2 minus the sine of 30, 1/2, times the sine of 45, root 2 over 2. And now it's just a bunch of algebra to simplify this. I get root 6 over 2 minus root 2 over 2, and that simplifies to root 6 minus root 2 all over 2. Done. So our next example is find the tangent of 11 pi over 12. So we don't have a reference, a common angle value for tangent of something pi over 12. So we're going to have to rewrite this as the tangent of two functions that we know, or two trig angles that we know the tangent of, that add to give you, or subtract to give you 11 pi over 12. Now I'm going to show you the trick, a little trick that's very useful in a case like this. Please don't put this in your work. It's just a little method to help you find it. Use scratch paper for it and then come right back over here. You don't have to show me how you got the two angles. You just have to get the two angles. So here's what we're looking for. Because the denominator is 12, I know I'm looking for some multiple of pi over 3 plus or minus some multiple of pi over 4, because 4 times 3 equals 12. And if I find a common denominator, in order to get that, I'd have to multiply 4 over 4 into the first fraction, and then I'd have to multiply 3 over 3 into the second fraction. So now I have 12 as my common denominator, and I've made the adjustment for finding a common denominator. I need now to find some multiple for the first fraction and some multiple for the second fraction with addition and subtraction that'll give me 11. Well, the obvious would be to try 4 plus 3. That's only 7. That doesn't give me enough. But 2 times 4 is 8, plus 3 is 11 pi, right? 2 times 4 and 1 times 3, and I used addition to get to 11 pi. Now, I don't want to use 8 pi over 12 and 3 pi over 12 because I don't have a reference angle for 8 pi over 12 and 3 pi over 12. But I can back up and undo my whole common denominator part. I can take out the part where I found the common denominator, and whatever's left over is the fractions I want to use. So I want to take 2 pi over 3 and add to that 1 pi over 4. So now I have angles I know how to work with, and you can confirm, I'm going to let you do it on your own, that 2 pi over 3 plus pi over 4 is indeed 11 pi over 12. Now I can just go straight to my identity. Right here I'm going to use the tangent identity. And so I need the tangent of alpha, and I'm going to call 2 pi over 3 alpha, the tangent of 2 pi over 3, and I'm adding, so the tangent adding means in the numerator I'm going to add plus the tangent of pi over 4 divided by 1, and if I'm adding here, then I'm subtracting here. 1 minus the tangent of alpha 2 pi over 3 times the tangent of beta. Okay, so I need to find the tangent of 2 pi over 3 and the tangent of pi over 4. So first, let's just use the unit circle, right? Again, I'm going to do this off to the side. It's not required that you show that in your work. We've already done that unit where you've proven that you know how to find this. So I'm going to first look in the unit in the first quadrant and find pi over 3. So pi over 3 is a 60-degree angle, where the y value is root 3 over 2 and the x value is 1/2. So the tangent is y over 1/2, or x. Denominators cancel, and so the tangent is root 3. But all students, I'm in the second quadrant because that's the first pi over 3 angle, and then I add to that to get to 2 pi over 3. I'm in the second quadrant. All students, sign is positive, which means my value is negative. Okay, so I've got my value for the tangent of 2 pi over 3. The tangent of pi over 4 is easier because we know that in the first quadrant, pi over 4 is in the first quadrant, so it's going to be positive. And the sine of pi over 4 divided by the cosine of pi over 4 is just root 2 over 2 divided by root 2 over 2. And so the tangent is 1. So now we have our values that we can plug in and solve this problem, or identify the tangent of 11 pi over 12. So the tan of 2 pi over 3 is negative root 3 plus the tangent of pi over 4, 1, over 1 minus the tangent of 2 pi over 3, root 3, negative root 3, so turn that to a positive, times 1. And so let's clean it all up. 1 minus root 3 over 1 plus root 3. And we want to rationalize the denominator using the conjugate. 1 minus root 3. So in the numerator we get 1 squared minus 2 times root 3 plus root 3 squared is 3. And in the denominator we get 1 plus root 3 squared. Oops, excuse me, that's not true. 1 minus root 3 squared is 3. Let's clean this up. 3 plus 1 is 4 minus 2 root 3 over 1 minus 3 is negative 2. Reduce, I get 4 divided by negative 2 is a negative 2. Negative 2 divided by negative 2 plus root 3, and then I can write it either way. Root 3 minus 2. Either way is fine. Okay, let's look at another example. This one's going to get a little bit tricky, fair warning. So we want to find the solution for the sine of x plus pi over 4 minus the sine of x minus pi over 4. And all of that equals 0. And we want to find it on the interval 0 inclusive to 2 pi excluded. All right, so what are we looking for here? Let's look for a second at what we're actually talking about. If I have some angle, let's just say this, some angle x, if to that angle I add pi over 4, so this is x plus pi over 4, and I also subtract pi over 4, x minus pi over 4, then the sine of, for that angle, the sine of x plus pi over 4 minus the sine of x minus pi over 4 would equal 0. But we're not actually looking for this angle here. We're looking for this angle, this x angle. Yikes, that sounds crazy. Why on earth would I ever want to do that? Well, the short answer is because you want to do really, really well in my class. The long answer is you're going to go into a mathy career someday, and you might have to save the planet from a meteor strike or from global warming, and this might be the exact thing you need to do, so we'll have to show you now. So let's use our identity, our new sum and difference identities. In this case, it's the difference identity. Oh, it's the sum and the difference identity. So first, let's set up the first sum identity. The sine of x plus pi over 4 is the sine of x times the cosine of pi over 4 minus, plus it stays the same, then the sine of this time pi over 4 and the cosine of x. Okay, so I've done this first one now, minus, now for the difference, I've got the sine of x times the cosine of pi over 4 minus the sine of pi over 4 times the cosine of x. Okay, I'm pretty sure that's right, equals 0. So now it looks like I can combine things if I can distribute this negative sign. So I'm going to change the signs of everything inside, and now I can disregard the parentheses. So I have sine x cos pi over 4 and a minus sine x cos pi over 4. So those cancel. Yay, that was helpful. And then I have a sine pi over 4 cos x, sine pi over 4 cos x. I have two of them. So that's 2 sine pi over 4 cos x equals 0. But 2, or sine of pi over 4 is root 2 over 2. Multiply that by 2. All of this equals root 2. But if I divide that by root 2, I just get cos x equals 0. And we know from the unit circle that the cosine function is 0 at pi over 2 and 3 pi over 2. So x has to be pi over 2 and 3 pi over 2. If I check my answer, I find that it's correct. Because, let's plug it back in, pi over 2, let's start with pi over 2. The sine, well, pi over 2 plus pi over 4 is 3 pi over 4. So the sine of 3 pi over 4 minus the sine of pi over 2 minus pi over 4 is just pi over 4. But that equals 0, right? So the sine of 3 pi over 4 is all students, so that's a positive root 2 over 2, and minus the sine of pi over 4 is a positive root 2 over 2 equals 0, and that is true. On the other one, the sine of 3 pi over 2 plus pi over 4, that actually puts us 3 pi over 2 is down here plus pi over 4. That puts us at 7 pi over 4. Or what we care about is that it puts us in the third quadrant where all students take calculus, where this is negative root 2 over 2. And then to that I'm going to subtract, or from that I'm going to subtract the sine of x, which in this case is 3 pi over 2 minus pi over 4. Minus pi over 4 puts me in the third quadrant where sine continues to be negative. Root 2 over 2 equals 0. These are question marks because we're checking. And so negative root 2 over 2 plus root 2 over 2 equals 0, so that is also true. So we found the angle, which happens to be either pi over 2 or 3 pi over 2 that fit this scenario. And you, my friend, have saved the world. Thank you very much.